Alright, so for this one, for Algebra 1, we're going to be talking about IXL BB13, which basically is matching a quadratic equation to the graph itself. And this one's pretty nice because it gives us our options and it gives us our pictures, so we just have to play some matchmaker and put them together. Um, I haven't really said this in any other video before, but if this is helpful to you, feel free to leave a like. I'm now a stereotypical YouTuber. Um, Maybe we'll plan something a little bit different once we hit 200 subs as well. Alright, let's go ahead and get into this one. With our two options here at the start, a couple different things I would have us pay attention to. Number one, whatever this leading coefficient is, so in this case it's the 2, and for this one it would be a -1 if you don't see the coefficient out front. What that does is it shows you that it shows you the shape of the graph. So a positive number like the 2 is going to give you a parabola. Remember, that's the name for these U-shaped graphs. A positive leading coefficient is going to give you a parabola that opens up, so something like that. And a negative number is going to give you something that opens down, or something like that right there. With that being said, there's also a C value, so the constant at the end, which is a 90 and a -28. Those are our y-intercepts. These are awfully large, though, relative to what we have on the graph, so let's not use those for this specific problem. I'm going to try to go through a little bit more examples than I have in the past. Maybe we'll run through the whole thing twice. Okay, for this one, this number is positive, so it gets matched with the parabola that opens up. We only have one option where that's the case, so that's this one. This gets matched because it's negative with one that opens down, so the arrows are pointing down. We also only have one left over there, so this one's not too bad to start out. Moving forward, well done, there we go. Similar thing here. This would be a +1. This would be a -1. So the positive number goes with the parabola that opens up. The negative coefficient goes with the one that opens down. Something else to look at here. I mentioned these constants at the end. Let's look at -4 first. That's the y-intercept, meaning it's where the U shape and the y-axis cross each other. So right here, you notice that is at -4. So that's another tell that this one goes with this graph. This -10 would tell us that they intercept or cross each other right here at -10, which they do. So another tell that we are on the right path here. Okay, let's keep moving forward. Okay, so they change up kind of how they give us these functions right now. That's not going to throw us too much right now. I'll explain those more when we need them. If you notice, both of these leading coefficients are +1s, and they both open up, so that's not really something that we can use here if they're exactly the same. However, this constant at the end, meaning it has no other variable attached to it, is a 5. If I look right here between 4 and 6, this one crosses at 5. This one crosses at 6. So the one with the +5 goes here. The one with the +6 at the end goes here. All right, now I said we didn't really need this part in this problem, but let's go ahead and explain it just for further use. This -2, if we think back to that zero product property that we talked about a little while back, we can set each of these individual sets of parentheses equal to 0. So x minus 2 equals 0, x minus 3 equals 0. And if we solve them by adding to the other side, so that's a +2 and a +2, we would get x equals 2. And pretty similar for this one. If I add 3 to both sides, we're going to have x equals 3 left over. So what that shows you is on the x-axis this time, we're getting x-intercepts, meaning where our parabola and the x-axis cross. If you notice this one, especially if we zoom in, crosses at 2. Oops, I'm off a little bit there, but at 2 and at 3. Let's see if I can't get that a little bit better. 2 and 3, there we go. That's another tell that this one goes with this. So just another option for you. I'm sure this is where if we were in class I would have somebody ask, okay, is it always going to be opposite? Technically it could lead to something else. I think everything that they give you on this IXL will end up being the opposite, so I don't know if you'll need to solve for any on here, but we'll pay attention to that and see if that does change going forward. Okay, let's go to the next one. Well done again. Okay, so again, both -2's, they both open down. Okay, we can't learn much from that. At the end, a -18 and a +4. Well, +4 is going to be on our graph for the y-intercept. And if I notice this one crosses at 4, so I know that would go with that first one. -18. Okay, this is pretty close. I think I could kind of visualize in my head that if we extended this and extended this down, it probably would cross at -18. And again, it's our only option right now. Eventually, towards the end, though, they give us a few more choices. Something else to pay attention to, though, if we did that zero product property, took away 3 from both sides. So let's write that out one more time. Trying to get better at not just flying through problems and actually explaining multiple examples here. Maybe if we do a second run through of this individual IXL, maybe then I'll speed up. So if we're subtracting 3 on both sides, I'm going to have x equals -3. Notice the squared. Remember what that means is I would have x plus 3 and another x plus 3. Well, if I had 2 of those, I would end up with x minus 3 twice. So if I go to the x value -3, I see that this one crosses at -3. And not only does it cross, it actually sits on that value of -3. It goes up, touches it, and comes back down. That's going to happen anytime you have the squared here. So if you see a squared, you're going to end up with a graph that has a vertex that just sits on the line. This one would be -1 and a +2 if we did the zero product property and solved those. If you notice, we cross it on the x-axis at -1 and at 2. So it works out for us here. All right, keep moving forward. Awesome. Okay, again, they both open up. I can look at this -6, and I see that this one crosses at -6, so I'm going to put that with this one, leaving this as our only option, but just to double check, this would be a +6 and a +7 once we solved those. If I zoom in, this is at 6, goes down, comes right back up at 7, so that works out there. This would be a -3 and a +1. If I flipped those, -3 and +1. So we kind of have backup methods just in case the leading coefficient or the constants don't give it away. Okay, we're still moving. 2 that have negative coefficients and have intercepts or y-intercepts that would be off the graph. If I move up to our factored version, so that's why these two things are equal. This is just if you actually did the probably product sum factoring, maybe did some common term first, this is what you would end up with. So for this one I would have, remember, if it's in just x plus or minus something, if it's in that form, you can basically flip it. So a -7 and a -3. If I look here, this would be at -7 and -3. So I know that this one, it's all wrapped together, goes with my first graph, leaving the second one for my second graph. But let's take a look real quick. That would be a +7 now and a +8. If I look here, +7 goes up right back down at +8. So we can kind of use the leading coefficient, the constant, these factors, and just kind of a process of elimination to get there. All right, keep moving. Okay, for something like this, while it may be more confusing because we don't have all those other pieces, kind of rewind back to what we talked about at the very beginning, the leading coefficient, negative and a positive, negative opens down, positive opens up. If you think about it, they don't show you a constant at the end, but they would both be +0 if there's nothing there. And then when we go to the graphs, they both actually touch at 0. So it still technically uses that constant, it just doesn't move the graph at all. Okay, we'll advance forward, submit, good work. Okay, so we talked about if you see a square here, we're going to have a vertex that just sits on the x-axis rather than cross through it. So this first one, remember it goes with that. I see that this one has a vertex that sits right on the x-axis. It would also give me a -6, and that's where we are here. It also opens upside down. All those things check out. For this one, it's going to cross the y-axis at 4. It's also going to cross the x-axis at -1 and +4, -1, +4. So a couple different things to check and make sure we're on the same page there. Okay, for this one, okay, they gave us kind of an easier one in my opinion here. Negative and positive, let's not make it more complicated than it needs to be. But if we want that extra reason why, -4 is right here, a +4 is up top there. We're getting closer to that 70 score that we've been going to more recently. We have 2 negatives now, so we can't really base off that. However, this one crosses at -9. This one's at -1, so from there I can sort those together. This also has that squared factored version at -3 that tells me it sits on the x-axis at -3. So another kind of backup reason why that works. I think this is going to be the last one we need to get to 70, and then maybe we'll go through it a second time a little bit quicker. +3 and +64. Well, this is one that we're going to be able to see. I can see this one crosses up at 3, so I know that goes there. This is my only one left, but again, if I look at these factors, this would be a -8 and a -4. Okay, I can see I cross at -8 and at -4. So again, we have multiple ways to arrive at an answer. Okay, that gets us to 70s. If you want to go further, just for your own benefit, we'll go through one right here. You notice at 70 it hits us with 4. However, it still gives us 4 options, so nothing too terrible here. If I look at my different options, I see only one has a negative leading coefficient, so I would probably pick that one first and go with the only graph that opens upside down. I also see that this one crosses at 2, so I would look out of my remaining ones which cross at the y value of 2. That would be this bottom left option. I would say be careful and go slow with these. I've had some issue when I was kind of preparing to record of dragging these in the wrong spot. It's very sensitive when there's 4 of them here, so just go slow. This one tells me I cross at -4. I see the -4 right there. This one would cross at 50. We notice this one would keep going up and probably cross at 50 eventually. It's also the only one remaining. Another way we could arrive there is with the one that has the 50 at the end. It has that squared factor at what would end up being a -5 Okay, we see this actually sits on the x-axis at -5. So again, we can arrive there even if it's not our just kind of leftover choice. Let's see if we did that correctly. I think I hit the button, it's just going slow. While we wait on it here, like I said, we will go back through. There we go. So let's hit refresh. Let's go back through one more time. This will be a bit quicker, but just so you can see some different questions. Again, right off the bat, I would look for negative leading coefficients versus positive. So that would be my go-to option. I would also do the same thing here. I have a positive and a negative. Also, this 39 and the negative 40 are a little big and would go off our graph, so that's not going to really be helpful yet. Here, they're both negatives, so this is where I would move on to the y-intercept, or the constant at the end. I have a -3 right there and a +2, so I would just make sure I go with the right one. Again, go a little bit slower than you think you need to. I've noticed sometimes these will be flipped, or at least in the one scenario I had that. And then sometimes they'll be a little sensitive. Like if I was trying to drag that real fast here, you saw it stopped and put it in this box, so just be careful. Okay, so I see two negatives again. However, this one crosses at -4 on the y-axis. This one would be at 0 since it doesn't have anything. So I see this one is at 0 for a y-intercept, and this one is down at -4. With these, they both open up. This one crosses the y-axis at 8, so I would put that in that spot. This is the leftover one, but also you would be able to use their factors. For example, a -7 would push us over here, and that is true in our case. Let's jump forward and do maybe one or two more examples. Let's run through one like this, and it can essentially work as two examples. Okay, I have two negative leading coefficients and two positive. I see that this positive one crosses at +1. So I see that out of my two positive options that open up, this one crosses at +1. So I'm going to bring that down here. This is my only other positive option. I see with the two negatives, one has a y-intercept of +3 and the other has a y-intercept of -2. Well, in my screen right now, I can see a -2 right here. And then finally, this is my leftover, which does cross the y-axis up at +3. Okay, we'll probably end this one here. Again, if you thought this was helpful, please leave a like, and maybe if we can get more subs, we'll do a different kind of video on here. All right, thanks guys, see you.